Bismillahirrahmanirrahim. Dear student, this is the third part of my video. In this video, we will discuss about the second case of the second order reaction in which A which is not equal to B. So in which A which is not equal to B, then there are two reactants A and B undergoes in a chemical reaction to give us product P. When time t which is equal to 0, then the concentration of the A will be A and the concentration of the B will be B and product is 0. So when time t which is equal to t prime, then the concentration of the A will become A minus x and the concentration of the B will become B minus x. So the rate of the reactions which is equal to K into A minus x into B minus x. So now we separate the variables in this equation. So in this side A minus x, B minus x is multiplied with K, and when we transfer it to the another side, then it divided by the dx. So equation becomes dx over A minus x into B minus x, which is equal to K dt. So now we integrate this equation and we put the integration signs on the both sides. So this term is resolving by the partial fraction method. This term is resolving by the partial fraction method. So now we will discuss the partial fraction method. So this is the equation 1 over A minus x into B minus x, which is equal to A over A minus x plus B over B minus x. In this equations, we put A dividing by A minus x and we put B dividing by B minus x. So multiplying the whole equations by the A minus x and B minus x. When we multiply the whole equations by the A minus x and B minus x, then we get 1 which is equal to A into B minus x plus B into A minus x. So putting A minus x which is equal to 0 or x which is equal to A in this equation, then we get the value of A. So the value of A will be 1 over B minus A. Then when we put B minus x which is equal to 0 or x which is equal to B upper equation, then we get the value of B. The value of the B will be 1 over A minus B. So now we put the value of A and B in these equations and we put the integration sign, and when we resolve this whole equations, then we get the final equations which is equal to 1 over A minus B into ln of B into A minus x divided by A into B minus x, which is equal to KT. So t is multiplied with K in this side, and when we transfer it to the other side, then it dividing by the 1. So equation becomes 1 over T into A minus B into ln of B into A minus x divided by A into B minus x. So the unit of the K will be dm cube per mole per second. If we want to calculate the unit, then this is called the slope of the second case of the second order reactions. So now my overall topic is completed. I hope that you would have a lot of understanding about this topic.